Hello everyone, welcome back to another Math Your Day channel. So in today's video we're looking at the derivative of a function using the first principle, or using the definition of derivative, right? So we said that the derivative of calculus is basically the limit, right? That's how we define calculus. So calculus is the limit, and hence when they say derive a certain function using the definition of derivatives, and hence you'll use the limit as h approaches 0 of the function fx plus h minus fx, all divided by h. Okay, so this is how we basically derive a function using the first principle or using the definition of a derivative, right? This is how we derive it. Okay, so remember we said that the limit is used to define the slope of a tangent line to a curve graph, but it is also used to define another operation of calculus, which is called differentiation, right? You guys might know this. Differentiation basically meaning deriving some equation, right? We will talk about that more when we look at some examples and explain the use of a derivative on a function, on the daily life, and etc., right? But for now, let us look at how to derive a function. So we'll be looking at some steps on how to use the first principle, and of course look at some examples thereafter, right? Okay, so when they say derive a function, right, so they basically, we said that okay, it is some slope, right, on a graph, right? It is some slope on the graph. Okay, so now how do we represent a derivative, right? So basically you will be given some function fx equal to, let's say, 3x, or you can also be given y is equal to 3x, right? So this is the same, so this is basically y, but this is of course the function notation. Okay, so when they say derive, so what is the notation that we use to show that the derivative? So there are multiple notation that one could use to to denote the derivative. You guys might be familiar with the f prime x, right? That's the first one. You can also say y prime x, or you can also say df over dx, right? You can also say, well, dx fx, right? All these are rather important. It doesn't matter which one you use, right? Doesn't matter which one you use, as long as you use it correctly, right? You use it correctly. I'll explain a bit later on another video what I mean by using this correctly, right? Okay, so this is the notation that we use to define, or rather to denote the differentiation or the derivative of a function. Okay, so I'll be looking at the derivative using the first principle of the definition of derivative. Now so how do we call this, right? So the most common one is given as dy dx, right? This is this might seem a little bit familiar, so but what does it mean? Well, you say, when you want to say this in words, you will say, well, the derivative of the function y, we are deriving the function y with respect to x, right? With respect to x, let's say we have 3x here. When I can say derive this function, and then you say, well, dy dt, right? And then you say this is equal to 3. Well, that is wrong from start, because here you're saying I'm deriving y with respect to t, but on this graph I do not have a t, right? I do not have a t, I only have an x, right? So if I say dt here, well, I'll assume that there is some t there raised to the power 0, because t raised to the power 0, that is 1, right? So I'll assume that there is a t raised to the power 0, and hence when I derive, I will get some 0 in that case, right? And hence in that case I'll get some 0, right? I hope that makes sense. Let us look at some example, or rather some steps on how to derive using the first principle, right? Okay, as we said, when you derive using the first principle, to be given as f prime x, which is equal to the limit as h approaches 0 of the function fx plus h minus fx divided by h, right? We did this on our prior video when we looked at the average, right? The average change. So in this case, we'll be looking at the derivative, right? So the first step that one should do is you have to basically find f x plus h. That is your first step that you have to rather the approach, right? The approach that one should do to get these questions correctly. You have to first find f x plus h, right? Do not plug in everything on this function as is, because you'll make some mistakes. So do it step by step. So the first step is to find this function here, right? So basically finding this, I mean that, okay, if I have some function fx equal to 3x, so in this case, if I say, well, find f2, well, it will tell me f2, it is 3 times 2, right, which is equal to 6. Now what did I do there? Well, I replaced x with a 2, because here in this case I had x. Now I'm replacing x with 2, right? Similarly, if I say fa, you will say I'm replacing a 2 in this case with a, so meaning wherever there is a 2, I will replace the a, right? Hence I'll get 3a, right? And hence if I put in x squared, I'll replace the a with an x squared, therefore I'll have 3 times x squared, and hence I'll have 3x squared, right? And similarly, if I have x squared plus 2, I'll replace the x squared with this polynomial here, so I'll have 3x squared, or rather 3 times x squared plus 2, right? And hence I'll have 3x squared plus 6, right, if you times this inside. Similarly, if I have x plus h, well, what does it mean? It means that I'll be replacing this part here with whatever I see on my bracket, so therefore I'll have 3. So here I had this, so I'll replace it with that, so it will be x plus h, which in that case will give me 3x plus 3h. I hope that makes sense, right? So I hope that makes sense. Let us erase this. So that is your first approach to these questions. You have to find f x plus h, right? And then the next step, right, step number 2, is basically subtract. So basically we are dealing with the numerator first of all. So you want to first deal with the numerator and then thereafter simplify, right? So step number 2 is to subtract the function fx with to subtract this from that, right? So basically the next step is to find x plus h minus fx. So trust me, whenever you do this step by step, you will get the answer correctly, because whenever you substitute everything on that formula as is, then you will make some silly mistakes. So make sure that you do this step by step. Okay, so the next step is to subtract fx from this here, so that we get the top part done with. And then step number 3, and then make sure that you add all the like terms, and the like terms, make sure that it is simplified completely and it looks nice, right? And then the next step is to divide whatever you got from step 2 with h, right? Divide whatever you got from h2 with h, and hence simplify everything by taking out the common factor, by taking out the common factor, by taking out the common factor and rationalizing in that case, right? So we did some rationalizing, we did some rationalizing, and then step number 4 is basically to simplify and all that. I wrote that in step number 3, but it's okay. So then step number 5, we need to do the answer that we got from step 4. We're gonna put it into this function here, or rather into this prime f prime x. So you will say, well, in that case I'll say, well, f prime x, make sure that you use f prime x, and then write the formula first, right? Then write the formula, and then thereafter whatever this is here, it's here on my step 4, and hence I'll take step 4 and then put it there in that bracket there. So it will be the limit as h approaches 0 of step 4, which is what I've simplified, right, on step 4, of course, which is what I've simplified, and hence I do the direct substitution and I'll get my answer. Okay, so let us look at some examples and see how we approach these questions. Okay, so let's say I have f x is equal to 3x, right? Let's say I have fx is equal to 3x, right? Go ahead and try this on your own. You can pause the video. So first of all, first step, what we want, well, we want fx plus h, which is what? In this case, I'm substituting this. I'm replacing x with this expression here. So meaning to be 3, and then whatever was on x, I'll put this here, which is x plus h, and then I basically distribute the 3 inside, therefore it will be 3x plus 3h, right? And then step number 2, to find fx plus h minus fx, right? So in that case, my fx plus h, remember, is what we got in step 1, so it will be 3x plus 3h, and then minus, make sure that you put this on the bracket, but for now it's only one term here, it's only one term. Let's say we had 4 terms, or rather we have 2 terms here. You do not want to make that mistake, so make sure that you say minus and then put everything on bracket, and then it will be 3x, and then you add, of course, it will be 3x plus 3h, and then you put in the negative inside. Remember, if you had 2 terms, then the negative will go in all those terms inside the bracket, so in that case it will be negative 3x, right? So here again it will be 3x minus 3x, that is 0, hence this one will give me 0, and hence here I'll have 3h, right? So my next step is to do what? Well, divide step 2 with what? With h, right? So I'm going to divide step 2 with h, therefore my step 2 I got 3h, and hence divide that by h. Then my step 4 is to simplify further. So if I simplify these two, well, I can see that the h and the h will move, and hence I'll have an answer of 3. And then step 5 is to now use the formula fx is equal to the limit as h approaches 0, fx plus h minus fx, all divided by h. Well, all these things here I've already done, so meaning I would have gotten a mark for these here, so meaning I do not have to do everything like in one step, right? So here I can just break them in simple pieces, and hence here I have the limit. Remember that this part here I've broken it down, and when I've broken it down I got a final answer of 3, has to be the limit as h approaches 0, in that case of 3, right? So here we do the direct substitution, and you can see that we do not have any h. We do not have any h here, so meaning my final answer in that case will be 3, right? I hope that makes sense. Let us look at another example. let's say you have y is equal to 3x squared plus x, right? Pause the video and try this on your own. Let us see. So the first step again, guys, you find fx plus h, right? Fx plus h. So that again, wherever, or in this case here, I could say, well, let y equal to fx, right? So in this case, this is the same as fx, right? So that would mean whenever I see an x, I'll substitute that with this expression here. So now I'll have 3 times this expression, because here there's an x, so it will be x plus h, and then squared because there's a square there, and then plus here there's an x, I'll substitute that, so it will be x plus h, right? Then if you add, let's expand the bracket first, so it will be x squared plus 2xh plus h squared, and then plus x plus h. Then if you distribute the 3 inside, it will be 3x squared plus 6xh plus 3h squared plus x plus h. Now, do we have any like terms? Well, you can see that we do not have any like terms, so you leave it as is, and then you go to step number 2. Well, step number 2 says fx plus h minus fx, right? So in this case, my fx plus h is this expression here, all this expression, so I'm gonna write it as is. So 3x squared plus 6xh plus 3h squared plus x plus h, right? And then minus, right? There's a minus there, minus this function, and this function here is this one here, right? So I'll put that in bracket, and then 3x squared plus x, right? Then if you add the like terms, you can see that the negative will go inside. If it will be 3x squared minus 3x squared, that will give me 0, so these two will cross cancel, and hence here again I have an x. It will be plus x minus x, because the negative will also go there, so meaning these two again will also move, and hence I'll have my final answer as 6xh plus 3h squared. Now remember, we said that here on step 2 we also like simplify, right? Or rather, my goodness, okay, so we got to step number 2, right, where we added the like terms, that, and then now I'm gonna go to step number 3, when I'm gonna divide this step number 2 with h, right? So I'll have 6xh plus 3h squared, all divided by h, right? So if you simplify, you can see that h is common in all these terms. If I can take out h as a common factor, then I would be left with 6x plus h all divided by h, and then I can just remove the h, and hence I'll have 6x plus h. Okay, then go to number 4. Well, number 4 says we must simplify, and we already simplified, right? So you're going to jump to step 5. We'll be using the formula f prime x is equal to, in this case, the limit to be equal to the limit as h approaches 0 of the function fx plus h minus fx, and then all divided by h. And hence I will do the substitution, because now I know that this part here is what I got on step number 3, right? So now I can say, well, the f prime x is equal to the limit as h approaches 0 of 6x plus h, right? So now you do the direct substitution. Well, I say wherever I see an h, I will substitute it with a 0. So in this case, that will be 6x. Here I do have an h, so I'll put a 0 there, and hence I'll get you will get an answer of, oh my goodness, okay, here I forgot another h, right? There was another h there, so I'm sorry about that. So here it was supposed to be plus h. Remember, here there was another h, so if you took out the common factor, there would be a plus 1. In this case here, there would be plus 1, hence here there's a plus 1, right? So yeah, there's a plus 1, right? So this will be now my steps my step 3, and hence wherever I see a h, I'll put in a 0. So in this case it will be 6x plus 0 because there's a h there, and then there's a plus 1, and hence my final answer will be 6x plus 1. Okay, so I forgot this h here, so remember here there will be plus h, and when you take out the h outside, when you put it inside there, you will get the same answer there, right, by taking out the common factor. Okay, now let's look at another example here. Let's look at this complex one here. Let's say I have fx equal to 1 over the square root of x minus 1. Okay, so you can pause the video and try this on your own. Totally fine. So the first thing, again, same procedure, nothing has changed. So this first step is to find my fx plus h, right? So in this case it will be 1 over, okay, the square root. If I see an x, I'll put in x plus h, right, and then there's this minus 1 there, right? Okay, so now the second step is to do what? I'll find fx plus h minus fx, right? So in that case I'll have this here, which is 1 over x plus h minus 1 minus fx, that's my fx, so it would be the square root of x minus 1. Okay, so now in this case you have to subtract. I hope that you guys know how to subtract these. Let's say you have 2 over 3 minus, let's say, 6 over some let's say 7. So the way you subtract, or it will be the same with addition. So with the way you subtract or add, the fractions, you basically times these two, right? So it will be 2 times 7, 2 times 7, and then you times these two again, so 3 times 6. In this case we have a negative, so I will put a negative. So if I had a positive, then this will be a positive. So in this case it will be 3 times 6, and then I times these two thereafter on my denominator. Therefore it will be 3 times 7, right? So basically times these two first, right? You go diagonally, and then you go horizontally, right, in the numerator. So in this case I'll have 2 times 7, that's 14, and then minus 18 divided by that times that, that's 21. Okay, and then you can just subtract or rather add the like terms on top. So here the same thing, I'm going to times these two diagonally, so they'll give me x minus 1, and then I'm going to times those two diagonally. I had a negative, let me just show you. Here we had a negative, so in that case it will be minus the square root of x plus h minus 1, and then I go horizontally, I will times these two, and hence now remember, whenever you have, let's say, square root of x times the square root of a, whenever you timesing the square root, whenever you timesing 2 square root or 3 or more, you can basically put the bases on one square root. In this case would be x times a, let's look at some number to prove that. Let's say 2 times the square root of 2. Right, 2 times the square root of 2, you can put that on one square root. Therefore it will be 2 times 2, and hence it will give me the square root of 4. Square root of 4, that's 2. Right, I can do this in multiple ways. Again, you have 2 times of that, so meaning if I have 2 times, well, I raise it to the power 2. If I raise it to the power 2, the 2 and the 2 will cross cancel, and then I'll have an answer of 2. Right, so this only applies whenever you have the two bases the same. Whenever you have two bases that are the same, the square root will move. Just like when I have x times the square root of x, my answer will be x. Right, if I have let's say 3x times 3x, my answer will be 3x. Right, but if the bases are not the same, right, if the bases are not the same, just like x times the square root of a, and then you can put them on one. I can put them on one square root. I hope that makes sense. In that case, so here we'll do the same thing here, the same procedure. So you have the square root, so I can put them on one bracket. So it will be x plus h minus 1 times x minus 1. Okay, I hope that makes sense. Yeah, now let us move on to step number 3. So now step number 3 is complete with, we subtracted. Now step number 3 is to divide whatever we got in step number 2 with h. Right, so step number 3 is to divide step number 2 with h. Now let us do that. So I'm just gonna bring this down a little bit. Okay, so on step number 2 we got this this here, so I'm gonna write it as is. So it will be x minus 1 and then minus the square root of x plus h minus 1, all divided by the square root of x plus h minus 1 times x minus 1, and then you divide all this by h. Now the question is, how do I remove the h at the bottom? How do I remove the h? Well, similarly, when we have, let's say we have 2 divided by 3 or divided by 2, or rather 3, right? Let's say 3. So how do I remove the 3? Well, if I want to remove the 3, then I'll times this part here by its reciprocal, meaning I'll times this by its inverse. So I'll times this by 1 over 3. Whatever I do on the bottom, I do on top as well. So in this case, you can see that these two will cross cancel, and hence I'll have 1 times 2, that's 2, and hence at the bottom 3 times 3, that's 9, right? So that will be the answer there. Okay, so here again I'll times this by its reciprocal, 1 over h, so meaning here on top I'll also times by 1 over h, right? So that I have an answer of x minus 1 minus the square root of x plus 1, or rather x plus h minus 1, all divided, here I have a h times that, to be h times the square root of x plus h minus 1 times x minus 1, right? Here at the bottom, of course, these two here will cross cancel. Okay, I hope that makes sense. Now going to step number 3, or rather step number 4. Step number 4 say we need to simplify. Now there's no way that we can simplify, but remember, whenever you are dealing with square root, I said this on my prior videos, whenever you're dealing with square roots, it's either you'll have to do the substitution method or the rationalizing method. So in this case, the substitution method will not work, so meaning I have to rationalize. So now we are, we are simplifying this. Remember I said on step number 4, where's my thing? On step number 4, or rather step number 3, we need to simplify. So by simplifying, I mean you need to take out the common factor, and when we are dealing with the square root, then we have to rationalize. I hope that you know how to rationalize. So in this case here, let us try to rationalize. So if you do not know how to rationalize, please go back to my prior videos. So here, remember we said that whenever you're rationalizing, you're basically writing this thing as is. We're not changing anything. Not changing the top part here. Write it as is. That would be x minus 1. Whatever you're doing on top, you're doing at the bottom as well. And whatever you change now, or rather what we change now, it will be the sign. It will be sign. So if this one was negative, this one will be positive, and if it was positive, this two will be negative, right? So now let us simplify. Now we're going to rationalize. Now we're going to do the FOIL method, because you have these two brackets here, or rather, these two brackets. So if you times that with that, remember the bases are the same, and hence the square root will move, and hence I'll have x minus 1. And then if you times that with that, the bases are also the same, therefore the square root will move, and hence in bracket we'll have x plus h minus 1, right? X minus h, and then all divided by, if you also do the FOIL method, you will get to this point here. If you do the FOIL method, because that times that times that will give you a positive, that will give you a negative, and they'll be the same. When they'll be the same, they'll just cross cancel, right? They'll just cross cancel, and then if you times these two, right, this is one bracket there, so these are two terms in this bracket, therefore I'll distribute this one bracket with these two. So let me just expand my thing here, so it will be this whole thing here times that, and then this whole thing here by times that, right? So that times that will give us h, right? Remember, whenever you have two square root, you can just put them in one square root and then times whatever is inside. So you will times whatever is inside in this case. So you have this part here, which is x plus h minus 1. Then these two are the same, therefore you can just say, well, this is x minus 1 squared. Okay, and then plus that times that, it will be h, and then the square root, the square root, you put the square root inside, and hence you will have that these two are the same, right? That is the same as this, therefore it will be squared. When you times, it will be squared, and then that basically will be x minus 1. Okay, now let's simplify further. So you can see that down on top, the x will move with the x, the 1 will also move with the 1, and hence I'll have the negative h on top. So I have negative h, right? So I'll have negative h all divided by here I'll take out h as a common factor, because here h is common in these two, therefore I'll have h, and then times this will be x plus h minus 1 times x minus 1 squared, plus this part here, which is the square root of x plus h minus 1 squared times x minus 1. Okay, so now you can see that these two here will cross cancel, and then this is times 1, of course, therefore negative times 1, that will give us negative 1, right? That will give us negative 1 all divided, let me just write it here at the bottom. I won't have that space. Okay, so it will be negative 1 all divided by, and then these two basically, remember, you can, the same way that we, whenever we had the same bases, we can put them in square root, or rather the same way that we are multiplying two bases, we can put them in one root. We can also do the opposite of that by basically separating them and giving them their own root. So in this case I'll separate them, therefore it will be x plus h minus 1 times that, which is x minus 1 squared. Remember that and that, that times that is the same as that. Remember you put them in one bracket. Whenever you're multiplying two bases that are in a square root, then you can put them in one bracket. You can also put them in separate bracket, just like how we did here. Then plus here I'll do the same, therefore the square root of x plus h minus 1 squared times x minus 1. Okay, I hope that makes sense. And hence, if you, this one here, remember this one is squared, therefore the square root will move with the square root, and this one, the square root will move with the 2 there, and hence I only have negative 1 all divided by this one here. It will be x minus 1 times the square root of x plus h minus 1, and then plus this one here, it will be x plus h minus 1 times the square root of x minus 1. sorry about that. Okay, so yeah, this is how you do it. Whenever you have a square root, whenever you're dealing with square root, you have to do this approach. Well, it is kind of a lot, but yeah, that is calculus. So then step number 5 is to use the formula. So it will be f prime x is equal to the limit as h approaches 0. Now the function will be fx plus h minus fx all divided by h. Now this part here I already simplified, which is this top part here. Therefore I can just substitute. It will be the limit be equal to the limit as h approaches 0 of now -1 all divided by x minus 1 square root of x plus h minus 1 plus x plus h minus 1 times, right, the square root of x minus 1. Okay, if you now use the direct substitution, because wherever I see h to be 0, therefore the h will move, right, the h will move, and hence I will have -1 divided by x minus 1 and then square root of x minus 1 and then plus x minus 1 times the square root of x minus 1. Okay, here we do have a common factor, which is this part here, so I'll take out that part as a common factor, hence I'll have -1 all divided by x minus 1 and then times the square root of x minus 1 and then plus the square root x minus 1. So you're basically done. I'm just simplifying it further, right? So they might say simplify it further, right? So you have to simplify this further. Okay, so here of course you can see that these two are like terms, therefore this is 1, this is 1, so 1 plus 1, there's 2. Therefore I have -1 times x minus 1 and then times 2 square root of x minus 1, right? So here again I could say, well, this is -1 all divided by the square root of x minus 1 squared, because this one here, the 2 can cross cancel and I'll still be remaining with this part here, right? And then here there's a 2, this 2 here, and then times x minus 1, right? And then -1, which is equal to 2. Remember we have the square root, therefore I can put them in one square root. These two are the same, therefore it will be x minus 1 cubed, right? And hence that will be your final answer. Again, you could have left it like that, or you could have also left it like that, right? It is correct as long as you remove the h. You could have left it like that, but if you simplify further, then you will reach to these 2 points here, right? Yeah, this one was a little bit too complicated. Hence why you need to follow these steps broadly, so that you do not make any silly mistakes whenever you're dealing with the first principles, because this one, trust me, this is for 6 marks here. You do not want to lose that 6 marks, right? You do not want to lose that 6 marks whenever you're dealing with calculus. Remember I said that calculus is the easiest topic. Yeah, optimization might be a little bit difficult but I will show you some tricks on how to do calculus, or rather optimization and integrations, right? And then of course the cubic functions. So yeah, but for now, please make sure that you master the first principles, because it comes out of every grade 12 exam papers. I know that for sure. It comes out on every exam paper, so make sure that you know how to use the first principle. And the square root, right? The square root might come in on the exams, of course, so make sure you are able to factorize, or rather you are able to rationalize and taking out the common factor and factorizing and all that. So I do have a homework for you. If you can just try these on your own, on your spare time, of course. Using the first principle, find the following derivatives. Let's say the square root of 1 minus x, and then 2, let's say fx is equal to let's say 2, okay, let's say 2 divided by x, and then number 3, let's say gx is equal to 1 minus x all divided by 2 plus x, right? Do try this on your own and see whether you will get or rather you know how to get these answers. If you do not know how, then comment down below. Do like the hit that like button, of course, and share the channel with other people struggling with calculus, right? So I really appreciate that. Yep, okay, so, and I'll catch you on another video when we'll be looking at the derivative, when we'll be looking at the rules on the derivative, or rather how to check whether your answer that you derived here is correct. And yeah, I'll catch you in another video.